Hey everybody, welcome back to RC with Adam. Super glad to be back here with you. Listen, I respect your time, so here's the bottom line of this 20-minute long video in case you don't want to watch the whole thing. We're talking about visually inspecting a quadcopter to make sure that, that you build your quadcopter correctly or that you're not getting trash if you buy a used quadcopter. So let's go through the main things that we're going to talk about, and I'm going to go more in depth. We're going to break the whole quadcopter down, but here are what you need to look for. For the motors, you want to make sure that the shaft is not bent. You want to make sure the windings are not burnt or blackened. They should look like copper. You want a free and smooth spinning bell. That's the outside piece that spins. You want to make sure the screws that are attaching the motor to the arm are nice and tight. You want the shaft screw or C-clip, and that's what actually holds the bell onto the rest of the motor. You want to make sure that's not missing and also not too tight or locked down. That'll keep the motor from spinning freely if it is. And you want to make sure that the motor wires are not cut or kinked. For the frame, you want to make sure that the arms are held tightly and not cracked or splitting. And you want to make sure the top and bottom plates are not cracked, and anything else to make sure it's not cracked or starting to come apart. The screws, you want to make sure those are not stripped out, the heads and the threads, and you obviously don't want them to be loose. And check that the standoffs are not bent or loose. For all the electronics, you want to make sure they're held tightly in place. They're not loose and rattling around inside the frame. You want to make sure the solder joints are clean and hold the wires in place if you tug on them lightly. Burn marks are bad, so if you see something that's burnt, that's probably bad and probably means it's not working. The insulation on all of the wires should not be missing or cut, and you don't want to see any exposed bare metal there. And you want the wires to not be too tight or pulled taut. They should have some slack so that they don't get damaged or get pulled off of the solder pads. And you want to check for corrosion or surface rust, and that could be an indication of water damage or other problems with the quad. The FPV camera, make sure it's not loose, and you want it to be in line and straight with the longitudinal axis of the frame. So basically pointing straight out from the frame. And of course, you want to make sure the lens is not cracked or loose or fogged or something like that. For the electronic speed controller and flight controller stack, in this case, this is a 4-in-1 ESC, you want to make sure that you're using silicone grommets for vibration insulation, and that they are bolted down firmly but not squished together like crazy. And you probably want to have a capacitor on the battery input pads. Capacitors improve the performance by cleaning up the electrical input, basically. For the video transmitter, make sure it has adequate space for cooling and it's not wrapped in tape or buried in the frame. And make sure that the antenna is connected, and do that before powering on to avoid burning out the VTX. And the antennas, make sure they're securely connected to their respective components. Make sure they're clear of the propellers and they're not bent or chopped up by the propellers, because that's a pretty common issue. And make sure they're not buried in the frame, and they need to be a few inches away from the frame to provide the best reception. If you want to see the full breakdown, we're going to go through it right after I tell you that this video is sponsored by none other than PCBWay. PCBWay makes custom printed circuit boards. That's what PCB stands for, and they have thousands of components to choose from, and you can actually design your own circuit board, send them the files, and they can build that circuit board for you, and they can actually assemble all of the components on there as an additional service, so it's ready to rock and roll as soon as you get it in the mail, which is pretty fantastic. Now, if PCBs aren't your thing, they also offer rapid prototyping services. So if you are an inventor like me, you can send them your files to have them CNC machine something, or injection mold something, or sheet metal bend something, or 3D print something. They have all kinds of options and materials that you can work with. If any of that sounds interesting to you, I'll have a link to PCBWay down in the description of this video. Let's get started with this teardown. Bam, what do we have here? It's a 7-inch quadcopter. That's right, this thing is pretty big. We're gonna kind of just go through things that I look at, and I guess maybe you'll learn from it and apply it to your situation. So let's get started. We're gonna start with the motors here. And by the way, this is a quad that I bought off of a fellow FPV pilot on Instagram. And I believe he built this himself as a basher 7-inch quad. And so I bought it with that understanding that it was going to be in, still flyable shape, but pretty rough shape. And so we worked out a fair price. So in case you're watching this, this is not to throw your work or anything under the bus. So we're all cool as far as I'm concerned. So let's get started with this. So one of the first things that I noticed, if we look at this motor here, you can see there is some discoloration in the motor windings there. It's kind of blackened. If we look at another one, the front left motor, it doesn't look as bad, and it should look like a nice bright copper kind of color. What that suggests is that this motor got pretty hot. It could potentially be damaged. I actually have not flown this yet, so I don't know. The other thing is with the motors, you want to just kind of spin them around, give them a good spin, hear how the bearings sound. I can't even really hear it, which is a good thing. You don't really want crunchy bearings. Yeah, I can't really hear this one either. So this is pretty good. These motors, by the way, these are Brother Hobby Avenger 1806.5, 1300 kV. These are kind of like the gold standard for 7-inch quads, as far as I can tell. So we've got some good motors on here, reputable motors. They should be pretty durable. Let's take a look at this motor. Feels pretty smooth, sounds pretty smooth. This one is maybe a little darkened on some of those coils, but overall, seems like it's in pretty good shape. Okay, if we flip it over and we just kind of look at the screws here holding the motor on, everything seems to be pretty solid. It's not wiggly as far as I can tell. Yeah, not too bad. I mean, not bad at all, really. It's on there just fine. So yeah, those are all good. So next thing is going to be the arms. The arms, are always the most likely to break, and I'm talking about these pieces of carbon fiber that are sticking out from the main body of the quadcopter. And these ones, they don't, they're not covered in tape, because sometimes some people like myself will end up covering the whole arm with tape. And so if that is the case, you probably want to take the tape off and see if the arm is broken or anything. But in this case, it all looks pretty good. This is a Source 1 V3 7-inch frame. And so it's like kind of like a budget frame. On the bottom here, we can see that some of these screws are pretty messed up. Like that guy right there. Looks like we have a little bit of, not so much surface rust, but just maybe a tiny bit, but it definitely is worn down quite a bit. Kind of looks like someone might have just used some pliers to tighten that. And also, it kind of looks like it's been stripped out. So getting that one off is going to be tricky. We're going to want to replace these screws, and it looks like these are, I think these are the stack screws as well. So anyway, that's just something to kind of, keep in mind. And then here we have a kind of a chip on the frame. And again, I'm not trying to nitpick. That's not the point, is to critique. I mean, we are critiquing it, but the point is not just to point out problems for the sake of that, but it's to give us an idea of what might be damaged, or how this person cared for this quadcopter perhaps. And I mean, with these, they're made to get beat up a lot. So that's just kind of going to happen. All right, let's go to the front here. We've got a camera up front, our FPV camera. This is what is this? A Lumineer. I can't remember the exact type. At first, it's okay, cool, FPV camera. But we can see that it is really wiggly. And it's just kind of stuck in there with foam and stuff. So there are not actually, I don't think there are screws holding it in. Are there? There's one screw. So we have a screw on this side holding it in. And then on this side, we do not have a screw. So again, something to keep in mind, because you're going to need to get another screw and put it in there. And then it also looks like this piece of foam here is keeping the camera tilt, where it's supposed to be, which is not ideal. You don't want to have to use a piece of foam. And it looks like it is also not straight in the body. So it's kind of off to the side. So that's something you want to think about. And again, the reason why you want to think about these things, especially before you fly, is because, like, well, now you'll know that, yeah, the camera is, you know, weird. The camera's going to be looking off to the side. So if it feels like this thing isn't flying straight, well, it's because you're just not looking straight because the camera's off. Coming back to the outside, we're just going to kind of do the external features and then take the top off and work our way in. Here we have the antenna for, I believe it's a TBS Crossfire Nano receiver. So we're missing the little plastic end piece, which I don't think that matters. I think that's just like a protector cap. And it looks like we've got this kind of rolled up in some tape stuff to fit this 3D printed mount. So no real problems with that. Looks a little bent up, but I don't think it's cut up or anything. So that's a good sign. Let me get my screwdriver and we'll take off the top. And you can see we have the XT60 coming out the top. Also, and he told me this, that the VTX antenna, this is an analog setup, the VTX antenna is not on here, so that's something else you want to think about. Just like, you know, if you were buying a quad, like, does it have all the parts to, like, actually fly or not? Here we can see the one of the screws, one of the standard screws has been swapped out for a different type, which is not necessarily like a problem or anything, but again, it's just kind of, you know, little things like that might tell you bigger things, or might tip you off to like other potential problems. So let's undo this. Good, not bad. Okay, and we got all the screws off. We can take the top plate off. Now notice we've got to kind of slide it to the end of this battery lead, because we can't take the battery lead off here until we unsolder it from the stack. Speaking of the stack, let's see what we've got in here. So we'll just kind of put this off to the side. All right, so first thing, we've got this TBS Unify Pro. This is a VTX or Pro 32. I've never used one of these. I think it's a really good analog VTX, but it's just kind of crammed in here, and it's loose, so that, you know, that could be an issue in flight, because everything's just kind of loose and wobbly in here, and generally, well, yeah, you don't want that. And one of the reasons why you don't want it is because it can affect your flight controller if you have things jiggling around, which we'll get to the flight controller in just a second because it's super loose. The receiver, the heat shrink tubing looks almost like charred, like a little smoky, which, you know, I don't know. I'm not sure what's up with that. And then our VTX antenna, you know, connector right here, this SMA connector, that's just it's kind of crammed in there, kind of awkward. We've got this piece of foam, and these are actually the landing pads that usually come with some quadcopter builds or quadcopter frames. So these usually go in the arms, and he has creatively incorporated them into the build for stabilization purposes. But hey, you know, do what you got to do. So, and then we have a buzzer in here. The buzzer is pretty solid. The buzzer's locked down pretty good. It's like double-sided foam tape in there. Moving on to the board here. Oh, and then here's something. Yikes. So our battery lead has this cut right here. So that's not good. That's definitely something we want to fix. It looks like just the insulation is cut. I think it's just the insulation. So not really a problem electrically, like in terms of like, you know, losing power, unless we short out or something else bad happens. So we would definitely want to at least tape that up with some electrical tape, or put some heat shrink over that or something to cover that up, because that's one of those things that, like, it might be fine, and then all of a sudden, you know, the power goes out to your quad or something fries, and that's because, you know, this thing got worked loose, or, you know, whatever happened, or whatever could happen, I guess. All right, so here we get to the main stack, and I believe this is a, what is this? He said it was a, it's a good stack. I think it's a T-motor stack. So it should be a quality stack. I think it's an F4 because it's got a micro USB. I'm not sure, but here's the thing. This is really bad. This is like a big problem. Like, don't ever fly if your flight controller is loose like this. So I don't know if he was flying around with this as loose as it is, because you will definitely have some issues. And then looking at the ESC, we can go. Let's just go ahead and take off these M3 lock nuts, and we'll just pull the whole flight controller board off. Yeah, I feel like these are hand tight, so that's probably what happened. All right. We have these little clear little O-rings that are kind of gripping onto the threads there, but we'll just pop those off. There we go. Ta-da! All right, kind of move all these wires out of the way if I can. What's catching up on me? Oh, the beeper. Let me see if I can pry this beeper out of here. Wow, that beeper's in there really good. Better than the flight controller, dang. Okay. Wowzers. Okay, that's in there really solid. Really solid. Yikes. Okay. So backing up just a bit, I do like how these motor wires are put on the arms here. It looks like they're pretty well protected. I'm not sure if this is like a particularly abrasion resistant cordage or covering. It looks like the outer sheath of some 550 cord. I think that's what that is. So it looks like it's all intact, which is good, because that is a common thing that you can get, you know, cut motor wires. If the blades slice over the top of your wires, you can cut them, and sometimes enough to actually, you know, break the electrical connection, which is really bad. So taking a look at this board, though, this ESC board, again, I'm not sure of the specifics on this, but one thing that really sticks out to me is the soldering right here. So this is probably like functional, most likely, but it does look like we have some cold solder joints going on. See how it's all like gnarly and kind of knurled and jaggedy, basically. And so that's going to be distinctive of some like a cold solder joint, or basically just a bad solder joint, which means that, you know, it could potentially come off. Like maybe it's not, it didn't adhere very well, essentially, to the flight controller. So that solder that is connecting the motor wire to the to the ESC board, basically, that could, you know, be kind of loose. Plus, it just doesn't look very pretty. And, you know, it's all about the looks. But no, these, I mean, they definitely are not pretty. They're really ugly. But I think they're going to be okay. I think that they will work fine. I do like how the motor wires are routed pretty cleanly. They're routed back around these standoffs and then under the stack. You know, I'm not sure if that's really the best for cooling purposes, but this is just kind of like a, you know, personal preference or whatever. It does kind of look like the board. I'm seeing some shininess on the flight controller and on the ESC board, so it's possible that there is some conformal coating. Let me get my black light and we can check. Yeah, so it looks like he did conformal coat the ESC board. And is it a stack? The flight controller stack? No, it looks like the flight controller stack is not conformal coated. Conformal coating is silicone conformal coating is a common way of waterproofing or water resisting electronics, and it commonly has a UV dye in it, so it will light up under a black light and it will kind of glow like you're seeing here. And that's so that you can see where you've already applied it. Let's take a look at our battery connection, because that's an important part. Let me try and get all these electronics out of the way, or at least some of them. There we go. We'll just kind of dump them all off to the side. Let's take a look at the back here. The connection where the battery connects to the ESC board. Again, we've got that really ugly solder joint. Is it strong? Is it going to hold? Probably, I think. But yeah, not super pretty. But again, we're not. I'm not trying to poo-poo anybody's building skills, and I think he said this was one of his early builds or something like that. So that's totally understandable. So if your soldering looks like that, but it works for you and it's strong and there's an electrical connection, then well, go for it. While we're here, we can see the frame. The frame looks good. There's tape residue and stuff, but it looks like it's not cracked. We can come up to the front here and remove these side plates. Let's see. Also, all the standoffs have this rubber like heat shrink on them. I'm not sure if that's for looks or if that's for like abrasion resistance or something. We can go ahead and pop out the camera. And so there's that plate. So we can see it's just been smushed in there. I'm not sure why that is. I think I see why. Okay. So on this plate right here, let's pull that plate out. And let's see, the front of the frame looks pretty good. So on this side, on this plate, the camera is still connected, but it looks like we have an adapter here. So this older style of frame, because they came out with the V4 now, which I think I'm actually going to get the V4 soon. But it looks like this camera was too small for the size of this frame, for the width of it right here. So it looks like he put in an adapter. I'm going to pull this. I'm going to pull the wires out from the camera. All right. Yeah, so we can see this adapter here to basically increase the size, but it looks like it just broke off of the other side, probably. That's probably what happened. It looks like we have a piece of a, I know what that is. That's a Race Day Quads business card with the VTX tables in there. I don't know why it's in here. I guess to give it a little bit more tightness, like as a shim or something. So anyway, oh, this is a Ratel Mini. That's what this is. Okay, a Ratel Mini. Anyway, yeah, so something like that, you're going to want to, figure out your own solution to that, and just keep that in mind, because you don't want your FPV camera wobbling all over the place and, changing pitch and all that kind of stuff. So again, just something to keep in mind. Before you send this baby off into the great blue yonder. One thing I forgot to mention is you want to take the arms of the frame and give them a little wiggle. Try and move them, and I can actually hear some wiggle here. Let's see if you can hear that. But yeah, I'm hearing a little bit of wiggle, so either it just needs to be tightened up. Let's see, so wiggle on, I think this arm, this front right arm, and then wiggle on the rear right arm, and I think that's it. So those might just need to be tightened up. Hopefully it's nothing more than that, but that's just another thing to keep in mind when you get a quad that you're not familiar with, because maybe it's flying weird or it's doing some weird jittery thing and you don't know why. And if you just check the arms, maybe that's causing it. Maybe it's a loose arm. Now, I haven't actually tested anything. I haven't plugged in anything. You could probably do that as a first thing that you do. And I would probably use a short saver, like a V-Fly short saver or a smoke stopper, just something so that if there is a short or something has happened to this, to where it would cause, electronics to fry when you plug in the battery, then, to keep that from happening. So that might be a good idea, because you never know, like maybe somebody just like crashed their quad and then like it's all messed up, but then they want to sell it, and so they haven't even like plugged it in again or something. So you never know. But anyway, so I am going to kind of put this back together, I think. I mean, as it is, it's a fully functional analog quad. I would like to make this digital, but I would need to kind of adapt this frame to fit the air unit, or get like a little get a Cadex Vista and put it in the back here. Maybe it looks like, yeah, we do actually have 20 by 20 mounting, so that could work actually. And anyway, I still think this will make a good at least basher 7-inch, and that's kind of what I'm moving towards, is the 7-inch arena. I'm getting there, and that's going to be a lot of fun. So I think that's it. Thanks everybody for watching. I hope this was helpful to you. Just kind of, I don't know, getting into quad stuff and taking things apart and learning how to, look at things in a little bit more detail. If you have any questions, leave them down in the comments below this video. And otherwise, get out there and fly something, and I will see you on the next one.
We get bars in our goggles that show